Hello guys, welcome back to my channel Cubics Lifestyle. I'm Fabe and today I'm here with the solutions for CBSE Standard 12 Mathematics, Chapter 3 Matrices, Exercise 3.2, question number 11 to 22. 11th question. If x into 2, 3 plus y into minus 1, 1 is equal to 10, 5, find the value of x and y. Answer. First, write the equation given in the question, then multiply x into each of the value and y into each of the value in the matrix, which would leave us with the equation 2x minus y is equal to 10 and 3x plus y is equal to 5. Consider them equation 1 and equation 2. Add equation 1 and 2 and we get 5x equal to 15. Then value of x would be 3. Substitute the value of x in equation 2. We would get 9 plus y is equal to 5. Y is equal to 5 minus 9, which is equal to minus 4. 12th question. Given 3 into x, y, z, w is equal to x6 minus 1, 2, w is plus 4, x plus y, x plus w, 3. Find the value of x, y, z and w. Now first write the given equation as per the question, and from the given equation we will find out four equations, that are 3x equal to x plus 4, 3y is equal to 6 plus x plus y, 3z equal to minus 1 plus z plus w, 3w is equal to 2w plus 3. Give them each equation 1, 2, 3, 4, 3 and 4, and consider equation 1 to find the value of x, that is 3x is equal to x plus 4, which would give us 2x is equal to 4, x would be equal to 2. Substitute the value of 2 in equation number 2, x in equation number 2. So in order to find the value of y, that is 3y is equal to 6 plus x plus y is equal to 6 plus 2 plus y, which would give us 2y is equal to 8, y would be 4. Now consider the equation number 4 to find the value of w, that is 3w is equal to 2w plus 3. That would give us 3w minus 2w would be w equal to 3. Substitute the value of w in equation number 3 to find out the value of z. That would be 3z equal to minus 1 plus z plus w, which is equal to 2z is equal to minus 1 plus 3, which would give us 2z equal to 2, then z equal to 1. 13th question. If f of x is equal to cos x minus sin x 0, sin x cos x 0, 0, 0, 1. Show that f of x into f of y is equal to f of x plus y. For that, first consider the given equation value of f of x, that is cos x minus sin x 0, sin x cos x 0, 0, 0, 1. So according to f of x is equal to this value, so then in order to find, when we consider f of y, substitute the value of x in this part, in this matrix into y, that would give us the value of f of y, that is cos y minus sin y 0, sin y cos y 0, 0, 0, 1. And in order to find f of x into f of y, we would multiply both of the matrix. That would give us cos x cos y minus sin x sin y minus sin x y cos sin y cos x minus sin x cos y 0 sin x cos y plus cos x sin y minus sin x cos sin y plus cos x cos y 0 0 0 1, which would give us, I hope you guys understood how we got this. We would be multiplying the first row into first column, then second column and third column. Then we would be multiplying the first row into second row into first column, second column and third column, and the third row into first column, second column and third column. That's how we got this value. And now the result of this would be cos x plus y minus sin x plus y 0, sin x plus y cos x plus y 0 0 0 1. When we look closely, the value of x and y in the given would be substituted by x plus y, so we can write that f of x plus y. So it is proved that f of x into f of y would give us f of x plus y. Question number 14, first part, show that 5 minus 1, 6, 7, 2, 1, 3, 4 is not equal to 2, 1, 3, 4 into 5 minus 1, 6, 7. Solution. Consider LHS part 5 minus 1, 6, 7 into 2, 1, 3, 4. Now, after we multiply the first row into say first column and second column, then we multiply the second row into first column and second column. We would get the 5 into 2 plus minus 1 into 3, 5 into 1 plus minus 1 into 4, 6 into 2 plus 7 into 3, 6 into 1 plus 7 into 4. That would result in 10 minus 3, 5 minus 4, 12 plus 21 and 6 plus 20. The 6 plus 20. 10 minus 3 would give us 7, 5 minus 4 would be 1, 12 plus 21 would be 33, 6 plus 20 would be 34. So this is the matrix that is the product of these two matrices. Now we consider the RHS 2, 1, 3, 4 into 5 minus 1, 6, 7. Which is equal to, after multiplying the first row into first column and second column, we multiply the second row into first column and second column, which gives us 2 into 5 plus 1 into 6, 2 into minus 1 plus 1 into 7, 3 into 5 plus 4 into 6, and 3 into minus 1 plus 4 into 7. That would leave us the value 10 plus 6, 16, 2 minus 2 plus 7 would be 5, 3 into 5, 15, 15 plus 24 would be 15 plus 24 would be what, and 39, and minus 3 plus 28 would be 25. So that when we consider both these matrices, it is not equal. Hence, it is proved that LHS and RHS are not equal. Then the second part, show that 1, 2, 3, 0, 1, 0, 1, 1, 0 and minus 1, 1, 0, 0, minus 1, 1, 2, 3, 4 is not equal to minus 1, 1, 0, 0, minus 1, 1, 2, 3, 4, 1, 2, 3, 0, 1, 0, 1, 1, 0. So, in the previous question, how we did it, we would be considering a similar situation here. So, first consider the LHS and multiply these two matrices. That will give us the value minus 1 plus 0 plus 6, minus 1 minus 2 plus 9, 0 plus 2 plus 12, 0 plus 0 plus 0, 0 minus 1 plus 0, 0 plus 1 plus 0, minus 1 plus 0 plus 0, 1 minus 1 plus 0, 0 plus 1 plus 0. That would give us the value 5, 8, 14, 0, minus 1, 1, minus 1, 0, 1. Next, we would consider the RHS part. That would be multiplying this two matrices. That would give us the value minus 1, minus 1, minus 3, 1, 0, 0, 6, 11, 6. When we look at both the value of RHS and LHS, we can see that both of the value are not equal. So since both of the value are not equal, we have proved that LHS is not equal to RHS. Thus proved. 15th question. Find a square minus 5a plus 6i if a is equal to 2, 0, 1, 2, 1, 3, 1, minus 1, 0. They have given us the value of a, that is this one. And as you guys know, the value of I is this 1 0 0 1 0 0 0 1. So first we would according to the question, we have to multiply a into a, that is this a square, that is 201 213 1 minus 1 0 into 201 213 1 minus 1 0. And subtract 5 into a, that is this one. Then we have to add 6 into I, which is equal to 4 plus 0 plus 1, 0 plus 0 minus 1, 2 plus 0 plus 0, 4 plus 2 plus 3, 0 plus 1 minus 3, 2 plus 3 plus 0, 2 minus 2 plus 0, 0 minus 1 minus 0, 1 minus 3 plus 0, minus 10, 0, 5, 10, 5, 15, 5, minus 5, 0, plus 6 into 1, 0, 0, 0, 1, 0, 0, 0, 1. That would give us the value 5, minus 1, 2, 9, minus 2, 5, 0, minus 1, minus 2, minus 10, 0, 5, 10, 5, 15, 5, minus 5, 0, plus 6, 0, 0, 0, 6, 0, 0, 0, 6, which is equal to 5. First subtract these two, that would give us minus 5 minus 1 minus 3 minus 1 minus 7 minus 10 minus 5 minus 4 minus 2 plus 6 0 0 0 6 0 0 0 6. Now we add both of them, we would get 1 minus 1 minus 3, 0 minus 1 minus 1 minus 1 minus 10, and minus 5, 4, and 4. So this is the matrix that we have to find. 16th question. If A is equal to this, prove that a cube minus 6a square plus 7a plus 2y is equal to 0. First, we would find the value of a cube, that is, first find the a square and then multiply another a to it, that is equal to this. A square would be 1 plus 0 plus 4, 0 plus 0 plus 0, 2 plus 0 plus 6, 0 plus 0 plus 2, 0 plus 4 plus 0, 0 plus 2 plus 3, 2 plus 0 plus 6, 0 plus 0 plus 0, 4 plus 0 plus 9 into 1, 0, 2, 0, 2, 1, 2, 0, 3. That would give us the value of a square would be this one. Now multiply another a to it. That would give us the value this. That is 21, 0, 34, 12, 8, 23, 34, 0, and 55. So this is the value of a cube. Now we would find the value of 6a square. as per for substituting in the equation. That is equal to 6 into a square, which we have found already in the previous question, that is this one. Now multiply 6 into a square, we would get 30, 0, 4, 6 into 5, 30, 0 into 6, 0, 6 into 8, 48, 6 into 2, 12, 6 into 4, 24, 6 into 5, 30, 6 into 8, 48, 6 into 0, 0, 6 into 0, 0, and 6 into 13, that is 78. Now we would find the value of 7a, that is equal to 7 into a, that is this one. 7, 0, 14, 0, 14, 7, 14, 0, 21. Now, now we will find the value of 2y, that is equal to 2 into 1, 0, 0, 0, 1, 0, 0, 0, 1. If you guys are thinking about the value of I, we already know that the value of I is equal to this. So I have just substitute the value of I even though it wasn't given in the question. That is equal to 2, 0, 0, 0, 2, 0, 0, 0, 2. Now substitute the value of each and every question, a cube, 6a square, 7a, 2y into the equation given in the question. That is a cube minus 6a square plus 7a plus 2y is equal to, first one a cube is this value minus 6a square we have found in the previous question, and 7a we have found in the previous part, and we have substituted all the values which we have found in the previous part, which would give us the value. First do subtracting these two, we would get minus 9, 0, minus 14, 0, minus 16, minus 7, 14, 0, minus 23, and adding these two we would get 9, 0, 14, 0, 16, 7, 14, 0, 23. Now we add these two, we would get an equation which is equal to, in which every element is equal to 0. So we would consider it as 0. Thus, this equation is proved. 17th question. If A is this one and I is given, in this one we have given, they have given that 1, 0, 0, 1, i's value is equal to 1, 0, 0, 1. It's because it is a 2 into 2 matrix. Now we have to find k so that a square equal to ka minus 2i. First one, we would find the value of 2a square, that is 3 minus 2, 4 minus 2, 3 minus 2, 4 minus 2. That would give us the value 9 minus 8 minus 6 plus 4, 12 minus 8 minus 8 plus 4, that is 1 minus 2, 4 minus 4. This is the value of a square. Now we have to find the value of k, right? So we would substitute the value of a square and a in the question, and also the part of I, that would give us the value. This is a square, that is 1 minus 2, 4 minus 4 is equal to k into 3 minus 2, 4 minus 2 minus 2 into 1, 0, 0, 1. That would give us 1 minus 2, 4 minus 4 is equal to 3k minus 2k, 4k minus 2k minus 2, 0, 0, 2. That will first, let's consider one of the equation, that is 1 is equal to 3k minus 2. That would give us the value for, to find the value of 3k, we would take minus 2 to the other part of the equation. So that is 3k is equal to 2 plus 1, that would give us 3. So cancelling both 3 from both sides, we would get k is equal to 1. So we have found the value of k, that is equal to 1. In order to verify, you can just substitute k in one of these equation, that is, let's consider the equation 4 equal to 4k minus 0, that is, substitute the value of k is as 1, we would get 4 minus 0 is equal to 4. So that's true, so we can be, it is verified that value of k is 1. 18th question. If a is equal to 0 minus tan alpha by 2, tan alpha by 2, 0, and I is the identity matrix of order 2, show that I plus a is equal to I minus a into cos alpha minus sin alpha, cos alpha. Answer. First, we would find the value of I plus a, that is 1, 0, 0, 1 plus 0 minus tan alpha by 2, tan alpha by 2, 0, which would give us the value 1 minus tan alpha by 2, tan alpha by 2, 1. And similarly, we would find the value of I minus a, that is this one. That would give us the value 1 tan alpha by 2 minus tan alpha by 2, 1. Now, we would consider the RHS part of the question, that is I minus a into cos alpha minus sin alpha, cos alpha is equal to 1 tan alpha by 2 minus tan alpha by 2, 1, cos alpha into cos alpha sin alpha, cos alpha. We would be multiplying both these mm, the first row into the first column and second column, and second row into first column and second column, as we do in the multiplication normally. So we would get the answer cos alpha plus sin alpha into tan alpha by 2 minus sin alpha plus cos alpha tan alpha by 2 minus cos alpha tan alpha by 2 plus sin alpha tan alpha by 2 plus cos alpha. That would give us, as you guys all know, that tan theta is equal to, or tan alpha by 2, tan theta is considered as sin theta by cos theta. So in this case, the theta is equal to alpha by 2, so we would be substituting the value of tan alpha by sin alpha by 2 by cos alpha by 2, that is, then the equation would be cos alpha plus sin alpha into sin alpha by 2 by cos alpha by 2 minus sin alpha plus cos alpha sin alpha into sin alpha by 2 by cos alpha by 2 minus cos alpha into sin alpha by 2 by cos alpha by 2 plus sin alpha into sin alpha by 2 by cos alpha by 2 plus cos alpha, which is equal to this one, that is, mm, uh, as we have written in here. uh, so we have, in order to add both the part, we have to find the LCM. So the LCM would be cos alpha by 2, so we would be multiplying cos alpha into cos alpha by 2, that would give us cos in alpha into cos alpha by 2 plus sin alpha into sin alpha by 2 by cos alpha by 2 minus sin alpha into cos alpha by 2 plus cos alpha sin alpha by 2 by cos alpha by 2, and minus cos alpha into sin alpha by 2 plus sin alpha cos alpha by 2 by cos alpha by 2, and sin alpha by 2 plus cos alpha into cos alpha by 2 by cos alpha by 2, which would give us, we all know that the value of the equation that um, cos alpha into cos alpha by 2 plus sin alpha plus into sin alpha by 2 is equal to cos alpha minus alpha by 2, and the equation minus sin alpha cos alpha by 2 plus cos alpha sin alpha by 2 is equal to minus sin alpha minus alpha by 2, that would give us the value of this one. So we would be substituting the values according to as per the trigonometrical equations, which we have studied in the 11th standard trigonometry. So which would be equal to alpha minus alpha would be alpha by 2 would be alpha by 2. Similarly here, so we would be substituting the value of alpha minus alpha by 2 with alpha by 2, that is cos alpha by 2 by cos alpha by 2 minus sin alpha by 2 by cos alpha by 2, sin alpha by 2 by cos alpha by 2, cos alpha by 2 by cos alpha by 2, which would give us cos alpha by 2 and cos alpha by 2 cancels, and which is equal to 1, and this would give us minus tan alpha by 2 and tan alpha by 2 and 1. So hence it is proved, since the LHS is equal to RHS, it is proved. Now let's see the 19th question. Okay, the 19th question is, a trust fund has rupees 30,000 that must be invested in two different types of bonds. The first bond pays 5% interest per year and the second bond pays 7% interest per year. Using matrix multiplication, determine how to divide rupees 30,000 among the two types of bonds. If the trust fund must obtain an annual interest, annual total interest of first part 1,800 and second part would be 2,000. Okay, let's see. So we have 30,000 rupees with us, and we have to invest it in two different ways, so that in the first part we would get 5% interest per year, and in the second part we would get 7% interest per year. Okay, so we can consider that the first part of the consider this rupees 30,000 as the total amount we have for investment. So when we break it up into two parts, let's consider the first part as x and the second part as 30,000 minus x. That is here like this. Then when we consider the interest which we get for the first part, that is 5% per year, and the second part for a year would be 7%. So let's write the matrices now. That is matrix of investment, that is equal to x and 3,000 minus x. This is the matrix for investment, that means the matrix invest, we are writing the amount we are investing. This is for the first part and this is would be for the second part. Matrix of annual interest per year is 5 by 100, 7 by 100. So this is the matrix of annual interest. To obtain, now the question is to obtain an annual total interest of rupees 1,800. So we will take both the matrices and multiply with each other, that is x 3,000 minus x, 30,000 minus x into 5 by 100, 7 by 100, which is equal to 1,800. So after we multiply, we would get 5x by 100, 7 into 30,000 minus x by 100 is equal to 1,800. We know that the annual total interest would be the sum of both the interest, total interest. So what we do is add both of these, that is we will get 5x plus 7 into 30,000 minus x by 100 is equal to 1,800. Multiply 100 into 1,800, we get 1,80,000, and multiply 7 into 30,000, we get 2,10,000. Um, Adding 5x and minus 7x, we get minus 2x. Now subtract 1,80,000 from 2,10,000, we get 30,000, negative 30,000. And to find x, divide 30,000 by 2, we get 15,000. So the investment of first bond is 15,000. So in order to find the investment of second bond, we will subtract the investment of first bond from the total amount of investment. That is 30,000 minus 15,000. That leaves us with the 15,000. So the investment in second bond is also 15,000. Next one is second part of the question, that is to obtain an annual interest of rupees 2,000. We have first consider both the matrices and multiply similarly as how we have done in the previous question, but instead of 1,800 we will give the value 2,000. So we will get the equation 2,10,000 minus 2x by 100 is equal to 2,000. Multiply 100 and 2,000, we get 20,000. 21 2 lakh, no, multiply 100 and 2,000, we get 2 lakh. Subtract 2 lakh 10,000 from 2 lakh, we get negative 10,000. In order to find x, cancel negative 2 from both sides, we get x is equal to 5,000. So the investment in the first bond is 5,000. So in order to find the investment in the second bond, subtract 5,000 from 30,000, we get 25,000. So the investment in the second bond is 25,000. 20th question. The bookshop of a particular school has 10 dozen chemistry book, 8 dozen physics book, 10 dozen economic book. Their selling price are rupees 80, rupees 60 and rupees 40 each respectively. Find the total amount the bookshop will receive from selling all the books using matrix algebra. So the question here gives there are 10 dozen of chemistry book, 8 dozen of physics book and 10 dozen of economics book in a particular shop, and for each of them is sold at a particular price, that is 80, 60 and 40 respectively. So the what we have to find is the total amount the bookshop will receive after selling out all these books, and we have to find it using matrix algebra. Now the solution. First consider the selling price as 3 into 1 matrix, that is 80, 60 and 40. Now the we know that the amount of book which is present, let's consider it in 1 into 3 matrix, that is that would be here, that is 10, 8 and 10. We know that a dozen contains 12 books, so multiply 12 this matrix into 12 and then multiply this whole into the selling price matrix. So we will get 120, 96, 120 into 80, 60 and 40, which will give us 9,600, 5,760 and 4,800 for each of the category. We have to find the total amount which the bookshop will receive after selling out all these books. So add all these for all these prizes for each and everyone, and we get a total of 20,000, 20,160. So the total amount received by selling all these books are 20,160. So I hope you guys understood. Assume X, Y, Z, W and P are matrices of order 2 into n, 3 into k, 2 into p, n into 3 and p into k respectively. Choose the correct answer in question number 21 and 22. 21st question. The restriction on n, k and p so that py plus wy will be defined are. So the when we consider py plus wy, let's consider py. P's order is p into k and y's order is 3 into k. We know that the order should be equal, the row and column should be equal in order to multiply with each other. So the k should be equal to 3. So k is equal to 3 and p and k should be equal. So we have found that k is equal to 3 and p is equal to k. And now we consider wy. Wy is n into 3 and y is 3 into k. 3 and 3 is equal. So n is equal to k. According to the same method I told, by which p is equal to k. So p is equal to k and n is equal to k. Since both are equal to k, they are equal to each other. So n is equal to p. So the answer would be k is equal to 3 and p is equal to n. So first option is the answer. Say 22nd question. If n is equal to p, then the order of matrix 7x minus 5z is. First option p into q, 2 into n into 3 and p into n. When we consider x, the x would be having 2 into n and z is equal to 2 into p. We know that n and it is said that n is equal to p. So when we multiply, it has the same order. Since n into 2 into n and 2 into p are n and p are equal, the order of the solution would also be in either terms of 2 into n or 2 into p, since p and n are equal. So according to the theory, among them the option B, 2 into n, is the answer. I hope you guys understood what I have said today, and by this I have completed the exercise 3.2. If you guys like the video, please like, share, comment, and for further updates subscribe to my channel. Thank you.